All right, so modeling one-to-many, we did take a look at that briefly last time we met. We took a look at faculty having many courses. We created a brand new course class, and we tagged the we tied both classes using two new annotations, right? The many to one and the one to many, right? We did talk about some of the challenges here. That typically when you model one to many in the object world, usually the relationship is in one direction, right? It is the parent who have references or pointers, right, to all its children, right, either as a singleton or as a single instance or as an array, right, that has an array of references to many instance objects. Usually, those instances typically don't have a reference back to the parent, right? That's very common. Right? I mean, they can, but it's uncommon, right? Unless you are trying to create data structures where are doubly linked, that you need to navigate the data structure in any direction, whether it's a graph, a multi-directional graph, or it's a linked list that you need to traverse in both directions. Usually, you would not point the parent to the children, the child to the parent. More common is just the parent has references to the child. But because we know that in relational database, it's backwards, it is the children who have references to the parent using a foreign key referencing the primary key of the parent. We need to be able to capture these two-way directionality between the records, right? In relational databases, it's common that whenever you have a reference, whenever you have a foreign key, primary key relationship, that creates a two-way navigation between any of the two records. You can navigate any which way just by making the primary key and foreign key equal. So to be able to support that feature in the relational world, here we have a faculty reference from the course referencing the parent, referencing the faculty author of this course. And to annotate that we are on the many side, on the star, right, of the relationship, right, the one to many, we're on the many side, we annotate it using the many to one annotation. And on the strong side, right, on the weak strong relationship, on the strong side, we annotate it using the one to many annotation, right? And here we have the saying that faculty has many courses. There's the many side. So faculty has many courses. So the course is tagged as the many to one, whereas here on the strong side we annotate it using one to many, and we also annotate how does the weak side refer to us? What field is it using to refer to us, so that we can create now the foreign key. We can say, we know that when we map this to the relational database, we need to create a foreign key on the other side called author, right, that references us in this record here. And indeed, the course references the faculty using the name of the field author as a base for the name of the field, and then adding underscore ID. Right, that's the standard naming convention that JPA uses for all its IDs and primary keys and foreign keys. Another thing that we discussed briefly was that yes. Yeah. True. Yep. Right. We haven't talked that yet, but once you start converting this and accessing this through a RESTful service, the RESTful service will try to convert and traverse this graph, and it would get into an infinite loop. Right. We need to stop it. Yeah.
So we use the repository to get the faculty by ID.
Yeah.
It would return a faculty object, and it also contains the list of these courses.
Yes. Yep.
Okay. So, but in SQL, we read a query just find by ID, it doesn't contain any courses information.
So yeah, that's what I was going to talk about in a minute. So we talked about that when you do the queries and you do the joins in relational databases, you can specify exactly which fields you want, right? So and also you can specify that you only want the fields from the left-hand side, or you only want the fields from the right-hand side, right? And in Java, usually when you get an instance object, and that instance object has references to all its children, usually all that would be loaded into the memory, right? That would be your expectation, right? You get the faculty, and all the courses are ready to go there, right? As part of the list of courses, and you should be able to just iterate over them, right? Now this brings a conundrum, because to be able to support being able to navigate from the parent faculty down to the list of courses, that means that there had to be a join between the faculty and the course, right? And they would have to retrieve data and records from both, right? The faculty, and then all the courses who had a foreign key reference to that faculty, right? Those would have to be loaded also into memory, instantiated, and then create the list of the objects. And so that brings into an issue. Well, what if those other records are, thousands of records? Would I need to join them and retrieve all of them? Well, the default is to not do that. Okay, the default is that the objects are lazily loaded, right? They're loaded only on demand, right? Those courses will only be loaded, right? Only if you explicitly ask for them, right? You say, okay, give me the courses. Then JPA will do another query, and we'll do the join, right? And retrieve the records and give you a list of the courses, right? The problem is that that would be very, very expensive, right? To load all that data into memory, right? One thing is to do the query at the console, where you do the join, right? And then you get thousands of records spit out, right? And then you can paginate through them and whatnot. Another one is to do the query from JPA and copy all those records into memory, where you're probably not even going to use them, right? You're going to maybe iterate over the faculty, displaying the username and whatnot, and you didn't even need the courses, right? Then why bother loading and doing all those join? Bring them into memory. That's very, very expensive. So the default is not to do it, right? The default is to be lazy, meaning I will not load it until you explicitly ask for them. You can configure that by using here the fetch. The fetch parameter allows you to configure if you want to be eager or do you want to be lazy, right? Meaning, do you want the object when I instantiate this faculty, right? Do you also want me to load all the courses, right? Maybe in our domain, in our implementation, we do need that. Maybe we need to calculate the faculty's load for the semester right away, and based on that load, I need to calculate the faculty's pay for this semester or whatever, I don't know, or some bonus. So I do need that information right away, right? I can't let it wait until later, right? So in that case, you can configure the fetch to be eager, meaning when you instantiate this and you do your query for your faculty, also do the join, to retrieve all the courses and populate this array or list of courses. Don't wait for me to ask for them, right? I want to have them ready to go right there and then. Okay. Did I answer your question? Okay. Another thing that we want to make sure, right, is that because yes. No, it needs it. Yeah, yeah, yeah. Yeah, it'll complain if you don't. Yep. So another issue of when you have the implementations of object-oriented world by default being one way, right? That usually is the parent who knows about the children, and the fact that the relational world is two-way, right? One of the challenges that it brings is that is that in the relational world, you can specify the two-way relationship just by saying that this foreign key is equal to that primary key, and you're done, right? There's no need, for instance, to tell the parent that the primary key is anything equal to some foreign key, right? The primary key doesn't know about the foreign key, right? It is the foreign key who knows about the primary key. But when you map that to the object world, we to be able to support the two-way mapping between the parent and child, now we have the lists of the courses lives on the faculty side, but on the course you have the author pointing to the faculty, right? So now you have truly two pointers referencing each other, right? Whereas in the relational world, it's as simple as just saying foreign key is equal to primary key, and you're done, right? You've created the two-way relationship. Here, you could do it both ways. You can either say, hey, faculty, add this course to the list of courses, right? But if you do that, well, wait a minute. Now the course also needs to know that this faculty is the author, right? It would be inconsistent to ask the faculty and say, hey, faculty, which one are your courses? Well, it's course 1, 2, 3, 2, 3, 4, and 3, 4, 5. But then look at the courses and you ask course number 3, 4, 5, who's your author, and not know that the author is XYZ, right? It would be inconsistent. So whereas in the relational world, you don't run into that inconsistency because there's only one place where you're capturing that one-to-many. The foreign key is equal to the primary key. You're done. In the object world, you can run into inconsistencies, right? So you have to always make sure that you update both places. So in this case, you can start both ways. You can start from the faculty's point of view. You can say, hey, faculty, here's a new course. I'm adding a new course. So usually we would just do what? If it's one directional, which is the default way you would implement it in Java, in the object world, you would just say this.author courses.add course and be done with it. You're done, right? That's what you would normally just do. But because we're supporting the two-way relationship references, we need to go back to the course and say, hey, course, did you know that I'm your author? And the course says, oh, I didn't know that, right? If you didn't know, well, yes, I am your author, right? Because we're trying to maintain the two-way relationship. You see that, right? So that's an additional, challenge or inconvenience because of what we call the impedance problem between the two worlds, right? Same way, right? We should be able to do it either way. We should be able to say, hey, faculty, add a new course, or we should be able to go the other way around. We should be able to say, hey, course, here's your author, right? And wherever you start, you should be able to have the same exact result. If we would have started from the course, say, hey, course, here's your author. Typically, if this would be a one-way relationship, right, you would just say this.author equal author. You're done, right? You'll be done with it, right? But because it's bidirectional, we have to go back to the author and say, hey, faculty, did you know that you just authored this new course, right? And then it would look for the list. It says, does it contain this course? It doesn't. Well, add it. Author.get author courses.add this. See that, right? We will see that this has. We'll revisit this, and we'll notice that in the non-relational world we have the same exact issue, right? Especially because in the non-relational world, there's no way to implement many-to-many, for instance, right? But in the object world, you can. You can have two objects, right, or two classes pointing to each other. Say the actor class with an array of movies, and you have a movie class with an array of actors. Yes, it would be inconsistent to say that this movie contained Schwarzenegger, but then when you ask the Schwarzenegger record, it doesn't have that movie listed there, right? It would be inconsistent. So to maintain consistency, you have to have both of them pointing to each other. And if you update one, you also have to update the other. And we know what problem that is when we have to update two places. It's very prone to errors that you can run into inconsistencies, right? So we try to avoid that. And so whenever you have these problems, we'll see that Certainly, we have when we're mapping object world to relational world. But when we introduce a non-relational world, we'll see that non-relational worlds allow you to store arrays in the database, right? So the same inconsistency that we can run here in the object world, we can run into that inconsistency again also in the non-relational world, right? So we have to be careful.